Buenos días. Lamento decepcionar, pero esta charla va a ser en inglés. Pero voy a hablar despacio y también lo contenido de los slides es en español. Si puedes acompañar. Pero hablo portuñol, no español. So today we're going to talk about generative UI with Flutter. And just a brief introduction before I tell you who I am. This is a topic that is very near and dear to my heart because I think it shows what the future could look like in the next few years and why Flutter makes so much sense, especially in the future of AI. So, for you guys that don't know me, I'm Leo Farias. I'm a founder, CEO, CTO of Concepta. That's a technology company in the United States. I'm an open source contributor. Some packages are FVM, Mix, SuperDAC, and there's some other projects there also. I'm also a Flutter and Dart GDE, pero no hablo español. And I'm very passionate about UI, UX, and developer experience in general. So a brief warning. We had some issues with the internet, so hopefully we won't have it. But there's going to be some live demos, which are going to be interacting with AI. I removed all the safety settings. That means that I can always control what's going to respond. So we might see some issues with the demo. So just to be prepared for that. Okay. So the most important thing is, if you came here to see us generating code automatically with AI, this is, I'm sorry to disappoint, but this is not the talk. So there's a difference between generative UI and what I like to call AI-assisted code generation. So AI-assisted code generation is what we're doing every day with ChatGPT and Gemini. But generative UI is a different approach for UI generation, leveraging AI, leveraging LLMs. So what is generative UI? So first thing, is everyone familiar with ChatGPT, LLMs, and AI in general nowadays? Show of hands. Okay. So one thing you see is that LLMs, they are great in understanding context. With very little information, they can make assumptions about understanding certain things. And this is great for linguistics. When it comes to speaking, translations, categorizations, anything in the linguistic side of things, LLMs will do an amazing job. And they also provide a very natural interface for us to interact with. But if you're familiar with GUI, and if you're a Flutter developer, you appreciate user interfaces, you know that user interfaces solve a different problem from natural language. You can interact with the UI. The UI can tell you what's important, the hierarchy of certain things. So, in a way, you can think of generative UI as if LLMs and GUIs, graphical user interfaces, came together. Okay? And this is a very important concept, and this is why I'm so excited about the future. So, the definition is, I think that's a good definition for it in Spanish, but it's creating dynamic interfaces that are aware of the context and is able to show actions to the users based on hierarchies and able to continue to provide feedback for the user and interaction. So imagine in a way that instead of you chatting, you can go ahead and interact with the UI. You can start a conversation, but then you can interact with it. And we're going to be doing a few demos about that. So what are some advantages that we have over chat? First, GUIs, they are more intuitive. They're able to show the context for the user much easier. They also provide a quicker feedback loop for the user. And depending on what you're trying to accomplish, it is much more efficient. And I think this is where it comes in Flutter. We've seen this explosion of AI, and it's safe to say that AI has already become a user interface. And very soon, it will be across all screens. And that's why Flutter fits really well for that, because If AI is going to be on all devices, then we need a framework that is able to provide a user interface for all devices. And this, I think it's a perfect fit for Flutter. So first thing, what some of you guys are probably asking is, how can LLMs understand UI? And a lot of LLMs nowadays, they have a concept of structured outputs. Have you guys heard about structured outputs, JSON responses? So essentially you can think of an LLM as a giant autocomplete. But now when you interact with it, you can ask to respond with a valid JSON, okay? So essentially, you have to create a schema, and you have to tell the LLM to respond with a structured output or a valid JSON. So this is how you do that with Gemini, but again, with OpenAI, ChatGPT is very similar. And you can see that it's fairly simple. I'm creating a schema that is an array, and I have to tell, this description is very important because it tells the LLM what this is, okay? And you can see that then I create it's going to be an array of objects, and I say that the object is going to be a recipe name, and again, I tell the description to the LLM. So essentially, the LLM is using the description to understand what this is. So it's the name of the recipe, and I say that nullable false. What does nullable false mean for the LLM? It means that it needs to respond with something. It cannot return empty, it cannot return blank. So it means that I can rest assured that the LLM is always going to populate this value according to this, and I can set if there are any required properties. Then what I do, I configure the response MIME type as JSON, similar to how you'll be calling a REST API, and you define the response schema. So with this, you just create a JSON API. And this is already a huge breakthrough because it means that you can very easily leverage LLMs to create APIs that do many different things that are responsive. And it's very simple. It's always going to return a valid JSON. It's really great. And then after that, you can just interact with it as a prompt, like you would with ChatGPT. However, when it responds with a valid JSON. So ask for a few cookie recipes, it returns some. They're probably not as popular in Latin America. I know they're not in Brazil. Peanut butter, Brazilians don't like that. But you can see that it's like some valid cookies that we return there. So here's a demo. So for this demo, I'm going to create a color palette generator. There's no purpose really in this, except to show you guys what can be done. This generator, I'm going to create a color, so it's going to have 4 different colors, and I would like the LLM to give a name to these colors, okay? I want to define a font family, so it can look really good, and actually define the color for each corner of the palette. So this is the schema, and I'll show a link after, so you guys can see. But you can see here that I define the name, an enum of all the possible font families that you can pick, and I can do the top left color, top right, bottom left, bottom right color, and I just say it's going to be a hex code. So essentially this, I'm defining everything I need, and I'm saying everything is required because I don't want to do validation. I want to be lazy with my validation, so I say, hey, return everything. All right, so here's for the demo. So I have some examples on the bottom. I'm going to press it just so I don't have to type it manually, but it's going to look like I'm typing it, and it's going to generate it, and hopefully the internet cooperates. So I just say tropical, and it returns everything that I asked for, the colors, and I went ahead and rendered there. So as you can see, I'm not saying, hey, I want something that is warm, inviting. No, I'm just saying tropical. And because the LLM is so good in understanding context, it is going to go ahead and try to populate and create the content there. Okay? Another one, vibrant. Hopefully I'm not pushing my luck. So you can see the same thing there. And one thing, and I told my daughter that I was going to mention again. So when I was showing my daughter this, I was trying to come up with like things that are colorful, but she suggested doing chocolatey pink unicorn as a color because she was curious to know what it looks like. So I'll go ahead and add it. I know everyone is curious. So this is what it looks like. And she was very impressed with this. So as you can see, with the example that I provided, I just created a color palette generator. That is an API. Anyone can generate it. You know, something that will probably be very difficult to do maybe a year and a half ago. Now it allows the creativity to take over. But now I don't want to show the payload. I want actually to respond in the chat with what it looks like, because maybe I want to try multiple palettes. So I'm going to do tropical again. Vibrant. So you can see that now instead of returning the text response, I'm rendering as a widget. Okay? And this allows me to now switch in between them. So you can see that now I'm generating, but now I'm interacting. I can switch. I can try different things. And however, I can actually see what the response looks like, as you guys can see. So with structured responses, there's a lot of different things that you can do, which would be very difficult before. And it's really exciting. Everything that we do nowadays from a feature perspective is interesting to see how we could leverage this feature. But LLMs, they do a little bit more than just responding with text and structured responses. They actually do an amazing job orchestrating APIs. Is any of you guys familiar with function calling on LLMs? All right, that's actually good, because I think function calling is really going to change the way we're going to be interacting with LLMs. So now, instead of LLMs just responding with text, and this is an interesting concept. In this case, Gemini, I define tools that LLM can use. And these tools are functions. So essentially I'm saying to the LLM, say, hey, when I interact with you, here are some functions that you can call if it makes sense. So if you need information that maybe you need a function for, you can use the tool. It means that you're going to choose when you're going to use. Hello? So the LLM is going to select when it needs to use this tool or not. Okay? So when I make a prompt, if it makes the decision that it needs a function, it's going to select the function. And what's more exciting is going to create the arguments to call the function. So based on the context, it's going to create the arguments and call the function with the arguments that the LLM provided. Okay? And this is something that is in beta right now for Gemini. And we're going to show a little bit of the demo, because it means that now with the response of the function, the LLM can now interact with even more context. So here's an example. This is a very robust lighting system I created for the demo. So, crossing fingers for the internet. So I'm going to go ahead and, the light is on. I'm going to go ahead and dim the lights by 20. And you're going to, hopefully it's going to output some context there. All right. So, I defined two functions. Gap brightness, so what is the current brightness of the lighting? And I also created another function called update brightness. So, the interesting thing is, I said, dim the light by 20. The LLM knows that I don't know what 20 means, because I know what it is right now. I guess I have to stay on this side. So, because the LLM doesn't know what it is right now, it actually knows that it needs to get the current brightness. It gets the current brightness, 90, and updates to 70. And then you have the response, I have dimmed the lights by 20% to 70, okay? So I'll go ahead and say, turn off the lights. So this is another interesting thing for the demo. In this demo, brightness 0 is off, anything above 0 is on. So when I say turn the lights off, the LLM says, I don't need to know what the brightness is. I can just set it to 0. So you can see that the LLM made the decision to not call get brightness. I didn't do it. It just made it, hey, I don't need this. I can go ahead and turn the light off. So I'll go ahead and do 2 more demos. I'm going to go ahead and set it to 80. So you can see, set it to 80. It doesn't care where it is right now. I can just set it to 80. But I can go ahead and lower by half. So when I go ahead and lower by half, you can see that to know what half is half of what? It went ahead and needed to get the brightness again. So you can see, this is a very simple demo, but it shows the capacity of reasoning of the LLM to know which tools to use and when. And this is when it gets exciting for generative UI. So right now how we interact, we ask, is the light on? Then the LLM says, I'm going to make a function call to get the lighting. It returns the brightness, 75. And then it responds, okay, 75, the light is on? Yes. Okay? So essentially the way we interact through natural language is this workflow. I asked, and it responds with yes. But we are talking about generative UI. So I came up with a new concept. Instead of text responses, everything in Flutter is a widget. Let's call it widget responses. And I want to do something a little bit different this time around. I want Gemini to call the function, but I would like to share the state of the function in a widget that I can interact with. So essentially is, I ask something for the LLM, it's going to call, but the response is actually going to be a state that I can go ahead and interact with, as I would in Flutter. So, same example. I'll go ahead and dim the lights by 20. All right, I showed the code, the example there. So it got the brightness, and instead of displaying the response, I actually created a widget with the states, and it means that now I've interacted with it. Maybe the brightness is great, but maybe I want to dim the lights more, right? So now it essentially allows me to maybe start an interaction through text, but then I can continue the interaction through the UI, right? I can turn it off, turn it on, and once I save it, it's there, and then I can continue to say, set it to 80, for example, and I can continue to interact. So the LLM is aware of what was the last state that I changed. So essentially, this is one of the, I think, very powerful ways that we can see how we're going to be interacting with LLMs in the future, and having these widget responses that allows us to be interacting with them. Okay. So I mentioned in the beginning that this is a very exciting time for Flutter. And this is something that I think we're going to see more and more. But what happens if the tool, the function, is not a function that is going to be calling? It's actually a scheme, a widget scheme. Okay? What do I mean by widget scheme? So I'm a user. I'll go ahead and send the prompt. But instead of having functions that can call, you have widget schemas that you can choose to render. Okay? So it means that Gemini now is aware, it's not going to generate code. It's going to use a generic schema, if it makes sense, to render the information. It's going to select one or more widget schemas. It will generate the arguments and pass to the widgets, to the schemas, in order to build the UI for you. Okay? So this example, I created, this is what again, very simple code, but this is what a drop-down widget schema might look like. You can see that a drop-down has a label. It can have the current value that was selected, and also it can have all the possible options the drop-down can have. And now I went ahead and I defined the schema. One thing you're going to notice is that it's generic. I'm not saying that the drop-down is, there's no business logic to it. It's not saying that this is this type of drop-down. All I'm saying is that there's a label for the drop-down, there's the options of the drop-down, and there's the current values of the drop-down. But for the LLM, all it is a drop-down. And now I create a builder. And then you can see that this is very simple. I have a data class, if you will, and I can pass the data class to a widget, to the values, in order to render. Very simple stuff, okay? Schema, data class, and a simple widget. Now what makes this interesting? What I can do is I can create many different types of schemas that the LLM can choose to use or not. So here's an example, and you can see that it's very broad. I'm saying, hey, I'm going to provide a schema, and this can have text fields. It can have no text fields, so you can see that it's nullable. Maybe it has 10 text fields. Maybe it has 1. It doesn't matter. You have drop-downs, same thing. Maybe you don't need drop-downs. Maybe you do need it. And color pickers, same thing. You can have multiple color pickers, no color pickers at all. You make the call on how you should go ahead and use this information. Now this is a demo, and referring back to the color palette generator, let's say I'm as a user, I have a color palette and I want to change the colors, but I don't want to go through an edit form, a giant edit form to change the colors. I only want to change the top colors. Okay, so one thing you can see here, it called the function say, okay, you want to change the color palette? What is the current color palette? I need to know that. So we went ahead and retrieved the current color palette. And then I got this information and I just said, here's the current color palette. Which widget schemas would make sense to use? So you can see that it selected top left color and top right color with the colors themselves. And now I have a color picker here that I can select it. I'm going to go ahead and do change font, which will be the case, I believe, of the drop-down. So you can see that the current font is Bungie. It actually says this is the current value, but also provides all the options based on the schema that I provided. So you can say that, imagine that you have a form that you don't want to go through a giant multiple step form. You want to change it, maybe one field, maybe a name, maybe something else. So you can start seeing that the way people are going to interact with the UI is not defined by us anymore. We're going to create these separate experiences, but the user defines how they choose to interact with it. We still have to build everything, but we don't control how the user is going to choose to interact with it. So I'm going to do an example of change everything. Let's see what happens. So same thing, you can see now that, okay, I want to change everything. Okay, drop down, color pickers, the font color, everything is there. So you can see the way I interact with it is very change everything. What's everything? Everything is the whole schema. So it's very aware of everything that it needs to do. This is really exciting going forward. And that's why I mentioned that the future of UI, and I know it's a time where people are freaking out and people are afraid. And I do think that where it's going to take us is going to be a very interesting place. And trust me, it's going to be a lot of work for everyone. But I do think that the future is going to be more about orchestrating user experiences than creating them specifically, defining what a user experience looks like exactly. We're going to create different story paths that the user can take, but the user will be able to choose their own story with the UI and LLM. So this is it. One last thing, the slide encode, I try to do a QR code. It seems like I could do a lot except generate a QR code. But you can find a lot of the code there, the reference and so on. And also Fabian, at 3:20, he's going to be elaborating more on a lot of the AI talk. So if this is something that is interesting, is a topic that you're curious about, I suggest going to this talk to continue to become familiar with some of these tools that LLMs are providing us. Thank you, guys. You have time for questions? All right, 5 minutes for questions. Go ahead.
Thank you. Thank you so much for the charla. Sorry. I wanted to ask about how much liberty should we give to the LLMs? Because sure, I can give the LLM liberty to change my logo, my font, my colors, but something that is very bad, I would say, about LLMs is that they can be overridden. That I can tell them, hey, generate this logo that I really don't want with a long prompt, and he will put that on my page. And should that affect negatively my brand?
So so everything that you see on the demo is basic. This is not a trained model. It's very simple prompt instructions. I'm saying, here's a color palette, go ahead and do that. I think when in production, depending on the market and the type of level of interaction you want, you have to go ahead and train as much as possible and try to do in a way where it's not providing the wrong type of information. Because you are going to have to guide it, but I think we're going to see a lot more maturity on this path. Does that answer your question? All right, thank you. Yes.
Good morning. Thank you for your talk.
Absolutely.
So my name is Alexis, and my concern or my doubt is about what about cost? If I have now one application and I want to integrate IA, what about cost? And in this case of Gemini, what is the access? What model I will be with access? I know that is the normal for free and the advanced for paid. So in the case of the Gemini API, what is the access level?
So the demo that you saw uses the Flash model. So it's the cheapest, fastest model there is. And one thing to think about is that when you break down the problems into smaller pieces, you can have cheaper models because you're not trying to do a lot of things. So first thing I suggest, break it down into small pieces so you can use cheap models. As far as cost, it's kind of like the Firebase problem, right? You need to architect in a way that is cheap. However, it's tough to say where we're going to be because every week I get an email from Google saying that we just released a new model that is 50% cheaper. There's a new model, 30% cheaper. So we are seeing very fast an optimization of those costs. But I do suggest to, obviously before putting something like this in production, play with some of these features in order to kind of become aware and understand what the cost could look like. Because if the user can do anything, then there's no limit. So you got to put some guardrails around that. But I think we're going to see the prices drop a lot within even the next year. Thank you. All right, thank you guys. I'll be outside if there's any other questions or anything like that.